Hi guys, welcome to my YouTube channel, and in this video I will briefly discuss about electric field lines. In this chapter I will discuss related to electric field lines, and electric field lines are discovered by Michael Faraday, and in this theory it represents that when any charge is placed in the center and a positive charge or point charge or test charge is placed in the vicinity, what will be the effect? This is any charge and we don't know, it is unknown, its polarity is unknown, we don't know what is its polarity. Is it either positive charge or negative charge? So we will place a test charge in its vicinity in order to check. This is a test charge, positive charge, and if we place in its vicinity, then its repulsion is produced. And if we change the position of this test charge, another repulsion produced. And if we change the position in the left side of the positive test charge, then another repulsion produced. And from these repulsions we may conclude that this source charge is also a positive charge, because positive charge can repel a positive charge. It means similar charges repel. So we have a test charge which is positive, and every time when we place in the vicinity of this positive charge or test charge, it repels. It means that this is a positive source charge. So similarly we can also find out the strength or polarity of the negative charge or negative source charge. In the other case, we can also discuss the similar theory and similar characteristics of this negative source. So if we place an unknown charge in the center, and if we place a positive test charge in the vicinity of this one, then we will find out, or we will feel that there is attraction produced. And if we want to verify this, we will need to change the position of this test charge. Then we will also feel the attraction. And in other case, if we change the position of this test charge, then we can also feel the attraction. So from these experiments and from these theory, we can understand that this test charge is attracted by the source charge, and source charge may be a negative charge, because this the attraction between positive and negative can happen due to their polarity. So this is a negative charge. We can justify that, or we can prove that. And in other theory, the electric field lines are coming towards the center or towards the source charge. So electric field lines pass from or travel from positive to negative term. So in the other case, you have seen that this is a negative source charge and electric field lines are coming towards its center. So we can find out the strength of the electric field by watching or by seeing the density of electric field lines. So in this region, electric field lines are very dense. We can justify that, and we can prove that this is a area of strong electric field. Or in this case, in the other case, when electric field lines are away, or the area is away from the source or center, then these electric field lines are scattered, and this is a weak electric field or weak electric field lines, weak region. And in the other case, if we place a similar charge with each other, and we know the concept of charges, and the characteristic of charge is that positive charge, two positive charge or two similar charge repel each other, and in this case electric field lines cannot cross each other from the center. So this region is known as free region or neutral region or free space, because in this region no electric field lines are present, because these two are positive charge or similar charge, and these electric field lines repel each other and they do not cross each other. In the other case, if we place a positive charge in front of a negative source charge, then what will happen? We know the theory of electric field lines. These electric field lines travel from positive to negative terminal, and from the center it moves towards the straight. So in other case, electric field lines move towards the bend, and as it is going to be bent, electric field strength is going to be decreased. So in this case, you can see in the center that the electric field lines are maximum, and this is a region of maximum electric field or strong electric field. In the other case, on the boundaries or on the edges, we can see that electric field lines are very scattered. So the strength of the electric field is very weak, and it is weak electric field region. So the theory of electric field lines is that electric field lines travel from positive charge to negative charge. So arrowhead show in this direction of the electric field lines in this case. In the other case, we can assume that two parallel plates are present in front of each other, one containing a positive charge and other containing a distribution of negative charge. The distribution of charges are equal, so we can say that the distribution of charges, and it is a uniform distribution of charges. And the theory of charges is that positive terminal to negative terminal. So the arrowhead shows that the starting point is positive terminal or positive point or positive source charge, and the negative point is the end point or destination. So it is a uniform electric field or uniform electric field lines from the center, and electric field lines are stronger, or strength is electric field is maximum in the center and weak electric field strength on the edges of the these plates. So the arrow lines or electric field lines show the strength of the electric field in that region. So in order to understand this one, or in order to conclude this, there are four characteristics of electric field lines. Electric field lines travel from positive source charge to negative source charge, that is why arrowhead shows. The other case is that electric field line cannot cross each other, and they move straight line, and they do not have a capability to cross each other. If they cross each other, there will be not a one source, there will be many sources. So the other case is that we want to check the strength of the electric field lines when the region, or the region where the electric field lines are dense. So it will be a strong electric field, and the region where electric field lines are not dense, so it is a weak electric field region. So in order to understand the electric field lines, we have discussed many things related to electric field lines, electric field direction, they do not cross each other, and the other thing is that electric flux. So how many number of electric field lines pass through some specific region. Up till now we have finished this, and the electric flux topic can be discussed in the next lecture. And please stay tuned and wait for the next lecture, and I will discuss the electric flux in very details, and you can see. Up till now I have finished. If you have any question, you can come up in the comment box.